Happy Groundhog Day, everybody. I hear the groundhog predicted 6 more weeks of winter again this morning, but he predicts that every year, and this is Texas, so, what does he know? All right, bye, groundhog. Today, we're going to learn about the coolest number. It's called E. It's the Euler number. All right, technically, the Euler number is the natural base E. It's the number that 1 plus 1 over n, all raised to the n power, approaches as n approaches infinity. If you were to graph that, and it will approach an asymptote, and that asymptote is going to be E, which is approximately 2.718. That's what you need to remember. 1828. 1828, 459, ... And it doesn't have a pattern, so it's just like pi. That's why E is one of the transcendental numbers that we learned about at the beginning of the year. Another cool way to look at E is if I were to graph y equals 1 over x. If I were to graph y equals 1 over x and take the area under the curve, if I started at 1 and stopped at E and took this area, which you'll learn more about how to do that in calculus, just take my word for it. If you found that area, it would equal 1 square unit. So you don't have to memorize any of that information, but that's where E comes from. All right, so we just need to know that E is about 2.718, and then we need to be able to work with it as if it was any other number. So here's some examples. If we were to simplify e to the 9th times e to the 6th, it follows the same rules that exponents always follow, and that is that we add them. 9 and 6 is 15. Or if we were to simplify 60 e to the 8th over 12 e to the 3rd, 60 divided by 12 is 5. And then e to the 8th over e to the 3rd, we're going to subtract our exponents. 8 minus 3 is 5. Or if I had negative 10e to the negative 5x all to the 3rd power, we would raise the negative 10 to the 3rd power and get negative 1,000. And then e to the negative 5x to the 3rd power, we would get e to the negative 15x, would give us negative 1,000 on top. And then take this to the denominator, e to the 15x in the denominator. So same rules as we've done with exponents before, but we're going to practice more of this. Now, if I asked you to use your calculator, there is a little E button. It is located third from the bottom on the left above the LN button, e to the x. You can do second e to the x. So if I asked you to use your calculator and evaluate e to the 6th, you would just punch in second e to the x and hit a 6 in for your exponent, and then write down the answer, 403.429. Give me 3 decimal places. Or if I asked you for e to the negative 0.28 power, I'm just making these up, you would hit second e. It gives you the exponent, so you raise it to the negative 0.28, hit enter, and then you're going to write down 3 decimal places, 0.756, like that. Easy, easy. All right, now we're going to apply this to the exponentials that we've been doing. Your natural base exponential function is going to be y equals, and then we might have some a value in front of it, and then e, and then we'll put to the rx. So basically, exponential growth and decay, only e is our base. And if e is your base, e is greater than 1, so it's growth. Now, if a was negative, that would change it to decay. And if r was negative, that would also change it to decay. Here's what y equals e to the x looks like when you graph it. I actually included a growth and decay for you to look at. The growth is the one on the left, y equals e to the x. We have our asymptote at y equals 0, just like always. We have our point at 0, 1, just like always, because even e to the 0 equals 1. Anything to the 0 is 1. And then when x is 1, your point's going to be at 2.718. Now exponential decay, if I were to raise e to the negative x, it would be the same graph, just reflected over the y-axis. It would be coming down, just like this, but we still have an asymptote at y equals 0, a point at 0, 1, and then we're coming down at, this would be 1, and then 1 over e is what that would be. All right, now when you take your test, you're not going to have a calculator, but I am going to expect you to be able to graph y equals e to the x. And you should definitely have memorized that e to the 1 power is 2.718. So we can definitely put when x is 1, y is 2.718 right there. You should definitely know that e to the 0 power is 1. So we should be able to put that point right there. You should know that there's an asymptote at y equals 0 without your calculator. And then I want to see, you need to know that e squared, you need to know e squared, and you need to be able to square 2.718. And if you do that, you should get about 7.4. So I do expect to see that on the graph too. So about right here. If you get these 3 points, the rest you can draw on like this, and I'll be happy. And if you know those 3 basic points, then no matter what I throw at you on the test, like y equals 4e to the 0.5x, you should be able to graph that by hand. Just make yourself a table. And we know e to the 1, so if I plugged in a 2 for x here, then I'd be doing 0.5 times 2 is 1. E to the 1 is 2.718. I could multiply that by 4 in my head or on the paper if I needed to, and I would get about 10.9. I could plug in, I know if x was 0, I would still get 0.5 times 0 is 0, so that would be 1, but then I'd be multiplying it by 4, so I know I'd have a point at 0, 4. I didn't mention it before, you also need to know for sure what e to the negative 1 power is, because that's 1 over e. So 1 over 2.718 is approximately 0.367, 0.368. We'll just go with 0.4, because we're going to be graphing this. So that I could then plug in a negative 2 for x. Negative 2, and 0.5 times negative 2 would give me negative 1. So I know e to the negative 1 is 0.4. I just need to multiply that by 4 and get about 1.6. So negative 2, 1.6 would be about right there. So now you've got 3 good points that you can use. Our asymptote didn't move. Our asymptote is still at y equals 0. It just, the 4 stretched it up a little bit, giving us this graph here. So finally, the part you've all been waiting for, what does this even matter for? What does this have to do with anything in the whole world? And the most common thing that we do with this is we use it for continuously compounded interest. You know how we talked about the interest formula that you have to have memorized? A equals P1 plus R over N to the NT? And that was with N being the number of times compounded per year. If you look at that closely, the bigger N is, the bigger your amount's going to be. The bigger N is, the bigger your amount's going to be. So if I compounded it monthly, I'd get one amount of interest. If I compounded it daily, I'd get a little bit more. If I compounded it every half day, so twice as much as that, I'd get a little bit more. So if you're trying to squeeze out every fraction of a penny that you can get from someone, you do it every minute, right? Or every second, or every half second, or even more than that. The most you could do would be a continuously compounded thing. And because we don't have an N for continuously, if we use the natural base E, that will give us the actual value. So the equation you need to know for continuously compounded interest is A equals P times E to the RT. PERT. There's a shampoo that used to be popular called PERT. But just once again, A is your after amount, P is your prior amount, E is your actual Euler number, 2.71828, da-da-da-da. Use the calculator, don't use 2.718. R is going to be your rate, and t will be your time. So let me give you an example problem. All right, so who can we think of that would want to squeeze every last fraction of a penny out of someone? And that would be credit card companies. So you're in college, you're a freshman, and you're walking around on campus, and they've got people with tables all over the place, clubs and organizations, and buy this, buy that, join us, campus Republicans and all this. And there's credit card companies out there with tables, and they're going to give you a free T-shirt if you sign up for this Visa, or it's usually T-shirts. I don't know why, but so you say, okay, yeah, I need a T-shirt, so you go sign up for a credit card, and it's got a 16% APR, which is not good, but that's pretty normal for a new person with without any credit. So yeah, you're like, yeah, I'll get this credit card, and then I can buy whatever I want. So you go spend $1,000 on that credit card. APR stands for annual percentage rate, but that's tricky. That doesn't actually mean it's compounded annually. These suckers are compounded continuously. So if you pay nothing, so you've spent that $1,000, well, now you don't have any money, your parents aren't giving you anything, so you say, yeah, whatever, I'll just pay it when I graduate, right? So you don't pay them anything. I'm not even going to count any late fees. Which usually they charge the late fees, and then they charge you interest on their late fees. But we won't talk about that. We'll just ignore that part. So not even counting late fees. What would you owe after 1 year? All right, so you go home. You say, hey, Mom, I got this credit card bill. I haven't paid it all year. And how much do you owe? Let's calculate that. We have our equation, A equals PE to the RT. We know we started with $1,000. E to the rate is 16%, so 0.16 times our time is 1 year. And we're just going to punch that in the calculator, and we'll see that after 1 year, we owe $1,173.51. And that doesn't sound so bad, except that that's $173.51 that you're not really paying for anything with that except for the fact that you haven't paid your bill. So that adds up, and it adds up fast. How much would you owe after 2 years? You could quickly calculate that. You'd owe $1,377.13. So imagine if you saved that till you graduated, because they're compounding your interest on top of your interest and on top of your interest. So it's going to be growing exponentially. And the longer that you wait, the more you're going to have to pay for nothing. I know lots of people that got in trouble like that in college because they thought, oh, it's free money. Luckily, you have your nerdy, responsible teacher who has never done that. But be like me, right? Don't use credit cards. Don't charge them up. Don't get sucked into that interest payment thing that some people do. And that is my life lesson of the day. All right, you guys have a good day, and I will see you tomorrow.